Hello everyone. Before starting the lesson, try the warm-up. Solve each triangle. Give exact answers. To solve each triangle means to find all the missing information, all three angles and all three sides. And to give exact answers means you might have to simplify a radical. So pause the video and see if you can find exact answers for the missing side lengths and the missing angles. Start with the angles. You know that all three interior angles of a triangle add up to 180. So if you subtract 90 and 45 from 180, you get a 45-degree angle. If you subtract 60 and 90 from 180, you get a 30-degree angle. Now I can use any trig ratio of 45 degrees to figure out what this missing side is. I chose tan. Tan 45 equals opposite over adjacent. I'll call that x over 1. Tan 45 times 1 is 1, so x is 1. That's that side length. To find the hypotenuse, I used Pythagorean theorem, and I got the square root of 2 as the side length. You can do a similar thing for the other triangle. If you look at 60 degrees, you can try sine, you can try tangent, but they don't give you nice numbers. Cos 60 is 0.5. That's kind of nice to make your math easier. Cos 60 equals adjacent over hypotenuse, 1 over something. So that something is 1 divided by cos 60, which ends up being exactly 2. So that's how I found the hypotenuse. Now the other side, use Pythagorean theorem again. 1 squared plus this side squared, we'll call it x squared, equals 2 squared. To solve for your unknown side, 2 squared minus 1 squared, which is 3. Square root of 3 is the answer for this as an exact answer. Now we're going to talk about special angles. And these angles that we dealt with in the warm-up, 45 degrees, 30 degrees, 60 degrees, these are special. They have values for sine, cosine, and tangent that we can get as an exact value, and we can work with those, and they're easy to use. So we're going to evaluate exact values of sine, cosine, and tangent for the angles 0, 30, 45, 60, and 90 degrees. These are our special angles. Now, to figure out what the exact values of sine, cosine, and tangent are for our special angles, we're going to use these special triangles. And believe it or not, these are the triangles that we came up with in the warm-up. So here's the first one where we had the 45-degree angles. We knew side lengths 1, 1, and the square root of 2. We can use this basic triangle to figure out the sine, cosine, and tangent of 45 degrees, and we can get an exact answer. So the sine of 45, well, here's 45 degrees, opposite over hypotenuse, 1 over root 2. The cosine, adjacent over hypotenuse, 1 over root 2 again. The tangent, opposite over adjacent, 1 over 1, which is 1. So if we want the exact value of the sine, cosine, or tangent of 45 degrees, these are the exact answers. Now what I mean is, if you were to type sine 45 in your calculator and you hit equals, it'll say 0.707106781. Now, that is not an exact answer, because even though you have all these digits, it's not as precise as what we have here. It has been rounded. The digits go on forever in a non-repeating pattern, so you cannot write the decimal version as an exact answer for these values. So if we want to have perfect precision, we use our exact values for sine, cos, tan of 45, and these are them. Now, 30 degrees and 60 degrees are other angles where we can find the exact values for sine, cosine, and tangent. Why don't you pause the video and see if you can figure out what the exact values are. So remember, if you're looking at the 30-degree angle, this is opposite. This is hypotenuse, so 1 over 2 is the sine of 30. Root 3 over 2 is the cosine, and 1 over root 3 is the tangent. For the 60-degree angle, this is now opposite. Root 3 over 2 is the sine. Adjacent over hypotenuse, 1 over 2 is the cosine. And the tangent, opposite over adjacent, root 3 over 1, which is just root 3. So these are the exact values for sine, cosine, and tangent of the 30 and 60-degree angles. So we've looked at 45 degrees, 30 degrees, and 60 degrees. There are other angles that we call special as well, 0 degrees and 90 degrees. So I want you to try to follow along with my thinking here. I have pictured a triangle, a right triangle. Here's the angle. This represents my 0-degree angle. Now obviously a 0-degree angle would not look like this, but just to illustrate what's going on, what would the side lengths be? Well, the height of that triangle, I hope you can see, would be 0. Because if this angle isn't anything, if it's 0 degrees, this part would actually be along here. It's in line with the same thing. So that height is actually non-existent. This length here and the hypotenuse would actually be the same length. If this is 1 centimeter, that would be 1 centimeter because they're lying along each other. 0 height, 0-degree angle. So when we talk about the sine of 0 degrees, well, it's opposite over hypotenuse, 0 over 1, which is 0. The cosine of 0 degrees, adjacent over hypotenuse. Well, since they're the same, whatever this is, divided by that, it's the same thing. The answer is 1. The tangent of 0 degrees, opposite over adjacent, 0 over 1, it's just 0. So 0 degrees has a sine of 0, cosine of 1, and a tangent of 0. We can do the same thinking when we talk about a 90-degree angle. If this angle in here is 90 degrees, then this side and this side would actually have to be in line with each other. This distance would be 0. This point would actually have to be over here at this point. So this side and the hypotenuse are in the same spot. So when we look at sine, cosine, and tangent of 90 degrees, sine is opposite over hypotenuse, 1 over 1, 1. Cosine, adjacent over hypotenuse, 0 over 1, that's 0. Tangent, opposite over adjacent, 1 divided by 0. You can't divide by 0, so that value is undefined. We can't put a number to define what that is equal to. So I've walked you through the reasoning behind where these numbers are coming from, as far as how you know that these are the exact values for sine, cosine, and tangent for these special angles. The reason we're using these special angles is to be able to do calculations without having to punch it into our calculator all the time. Now, instead of trying to draw these special triangles for these special angles to find sine, cosine, tangent, it might be more helpful for you to have them listed in a table like this. And you'll find this on your unit summary sheet. You can write the sine, cosine, and tangent for all of these special angles. And I already walked you through what the numbers are and where they came from, so just fill it in. So pause the video and make sure you have this chart in your notes that you can refer to as we go through some problems. So here's the first example. Determine the exact length of x. Notice it says exact length, so I'm not going to round any answers. I might have radicals in my answer, but that's what I want. I want the exact length. So here we have an angle. We want the opposite side. We have the adjacent side. So we think about whether we use sine, cosine, or tangent. If we want opposite and we have adjacent, we need both of those in the equation, opposite and adjacent. So we won't use sine, we won't use cosine, we will use tangent because it involves both opposite and adjacent. So the tangent of the angle is equal to opposite over adjacent. Plug in what you know the angle is 60 degrees, opposite is x, adjacent is 15. Now here's where we're going to use our special angles in that chart you just copied down. The tangent of 60 degrees is the square root of 3, exactly. So now we're going to solve our equation. The square root of 3 is equal to x divided by 15, so x is equal to 15 times the square root of 3. So as an exact answer, x is 15 root 3 feet long. So this isn't really any more difficult than anything you've done previously. It's just we're getting an exact answer. So at this point, instead of going to our calculator, we just use that chart that we came up with to get our exact answer for the tangent of 60 degrees. Now this question, on the other hand, looks more complicated and more difficult. It's only going to be more difficult because of the algebra that we're going to be doing, but why not have some time to practice the algebra that we've learned? We have an angle, theta, that we want to figure out what the measure of that angle is. How many degrees is it? We want an exact answer. We know the adjacent side and the hypotenuse. So that will help you determine whether you're using sine, cosine, or tangent. So here's the adjacent side, here's the hypotenuse. Use those in your equations. You might have to expand and simplify in order to get a simpler answer, and you'll have radicals in it. So try to simplify your radicals as much as you can. Use all that good knowledge of algebra that you learned in previous units. So pause the video and see what you can come up with for this angle right here. Well, if I have the adjacent and the hypotenuse, I'm going to use cosine. The cosine of the angle is equal to adjacent divided by hypotenuse. So I just plug in my adjacent and my hypotenuse for the numerator and the denominator. I expand and simplify, and I end up with this. 2 over 4 reduces to lowest terms, 1 over 2. So I've got root 3 over 2 as lowest terms. Now, the cosine of theta is equal to root 3 over 2. So look at your chart. For which angle is the cosine root 3 over 2? 30 degrees. So that's our answer. Angle theta is 30 degrees. All right, why don't you try this one on your own? Determine the exact value of sine 45 multiplied by cos 45 plus sine 30 multiplied by sine 60. You know the values of these ratios. You can plug them in, you can expand and simplify, you can get an exact answer. So pause the video and try this on your own. Sine 45 is 1 over root 2. Cos 45 is 1 over root 2. Sine 30 is 1 over 2. Sine 60 is root 3 over 2. Multiply these together. 1 times 1 is 1. Root 2 times root 2 is 2. Multiply these together. 1 times root 3 is root 3. 2 times 2 is 4. So I end up with root 3 over 4. I'm trying to add these two fractions together, so I need a common denominator. Easiest way to get a common denominator is turn 1/2 into 2/4. Now you have fourths as the common denominator. Now I can just add the numerators, 2 plus root 3, and my denominator is 4, so I end up with 2 plus root 3 over 4. I can't simplify this any further, so that's it. All right, example 4, using exact values, show that sine squared theta plus cos squared theta equals 1 for each angle. So basically what we're going to do is we're going to take the sine of our angle and square it. We're going to take the cosine of our angle and square it. We're going to add those together and show that it's equal to 1. We're going to do that for different angles. And it should work out that it's always equal to 1 regardless of what the angle is. So I'm showing you what I mean with the first one. The angle is 30 degrees. Sine squared of 30 degrees plus cos squared of 30 degrees. What's that equal? Well, sine of 30 is 1 over 2. Cos 30 is root 3 over 2. If I square each of those, I end up with 1 over 4 and 3 over 4. If I add those together, I get 4 over 4, which in lowest terms is 1. So here I'm showing that this is equal to 1. Do the same thing with 45 degrees and 60 degrees. Pause the video and try it. So here you go. In each case, you get an answer of 1. Now, why do I bring this up? Well, you'll see later on in this unit, we're going to talk about something called trigonometric identities. This is one of them. And this is just trying to show you that it doesn't matter what the angle is. If you square the sine and square the cosine and add those together, you always get an answer of 1. You'll learn more about trigonometric identities in a later lesson. So for now, if you could do this, then you're good. Now, if you're up for a challenge, I'm going to combine ideas from the last lesson and this lesson. Here we have a reciprocal trig ratio, the cotangent, and we're going to calculate using exact values this expression. We're going to evaluate this expression here. So I'm telling you that the cotangent of the angle is square root of 3. With that information, calculate sine theta times cotangent theta and subtract the cosine of squared. See what that is equal to and get an exact answer. So pause the video and try it. If you're not sure how to get started, maybe this will help you. The cotangent, remember that's the reciprocal of the tangent. So if the cotangent is root 3, then the tangent would be 1 over root 3. Look at your chart of exact values for those special angles. Which angle is this? Which angle has a tangent that's 1 over root 3? Well, it's 30 degrees. So now that you know what the angle is, you can evaluate this expression here. And now that you know that the angle is 30 degrees, well, sine of 30 is 1 over 2. The cotangent of 30, I already know that. It's up here. It's the square root of 3. And the cosine of 30 is root 3 over 2. We square that. It's 3 over 4. Multiply these together, root 3 over 2. We're subtracting fractions, so we need a common denominator. So I end up with this. 2 root 3 minus 3 over 4. That's the exact answer. So we have special angles, 0, 30, 45, 60, and 90 degrees. Those are special because we can find the exact values of their sine, cosine, and tangent, and by extension, the cosecant, the secant, and the cotangent. We can use these exact values to find exact answers for side lengths and angles when we use sine, cosine, and tangent. So as you practice, reach out for help when you need it.